This week we're working on the Corolla. We're gonna pretend that it is not a OBD2 car, and we're gonna look at different sensors and their voltages. So here you can see with the key on, engine off, on the power side, we're getting 2.7 volts.
So the engine on this Corolla has been running for about 5 minutes, and you can see we're still hooked up to the ECT 5-volt reference side. And as the engine is warming up, since it is a negative coefficient thermistor, as the engine temperature rises, the resistance of that thermistor goes down, which means that less voltage is required and less voltage is being eaten up by that sensor. So originally we were at 2.7 volts and we've gone down to 1.55 volts so far. So the engine's been running for about 20 minutes now. You can see our coolant temp is 158 and our voltage on the reference circuit is down to 1.04, down from 2.7 originally at 68 degrees Fahrenheit.
So now we're on the signal of the intake air temp sensor. You can see we're hooked up and we're reading 2.6 volts.
Okay, we've tested this previously in Auto 240 class, but if we were to blow cold air into the intake air temp sensor, the voltage on this meter would rise, and if we were to blow hot air in, the voltage would go down. So today, the second lab day of this module, we're continuing on with this OBD1 sensor signal testing, and we are tapped into the signal for the throttle position sensor, and it's actually integrated into the same connector that controls the throttle plate and motor. And so you can see without any movement of the throttle plate, we're sitting at 1.1 volts. And if Zach moves it, you can see the voltage goes way up. And that's that potentiometer, as that pedal moves, is changing the voltage.
So now we're set up. Gabe's got us hooked up to the gas pedal position sensor. You can see it's at about 1 volt. And then whenever he presses the pedal down, you can see it goes up. It's because it's a potentiometer.
That's forward.
And that's all the way to the floor.
Okay, so now we're tapped into the crankshaft position sensor signal, and we've been running the car for a little while now, and it's sitting at 1100 RPMs. You can see our frequency is at around 630 times per second that it's seeing that signal, that it's passing a tooth. And so I'm going to do my best to explain this, but we believe that since there's 630 hertz, it's seeing a tooth 630 times every second. There's 32 teeth on the crankshaft reluctor. We learned that from a previous lab. So if you take 630, the frequency, divided by the amount of teeth on the reluctor, that's how many times that the...
So now we're on the camshaft position sensor. You can see we're still in hertz. And then when Gabe gives it a rev, you can see it shoot up with the RPMs.
So I can't explain this in detail, but I'm pretty sure this is correct. So for every 19.5 revolutions of the crankshaft, there are about 9.33 revolutions of the camshaft, and this is at 1100 RPM. And that makes sense because there's about double the revolutions of the crankshaft as there are the camshaft, which agrees or coincides with the fact that the camshaft rotates once for every 2 revolutions of the crankshaft. So I just thought that was interesting to kind of do those calculations and see our results and see the correlation between the frequency we can read and the camshaft and crankshaft.
So now you can see we're set up on the mass airflow wire, on the signal wire, and we're at 1.7 volts. And now Gabe's gonna give it a rev. And you can see how the voltage goes up with the airflow and the RPMs.